Hey everyone, have you ever stopped to think about something as simple as an ice cube melting or a match burning? I mean, they're both changes, right? But they're not the same at all. One just changes how something looks, but the other, it changes what it is. That's exactly what we're diving into today, the huge difference between physical and chemical changes. So let's start with a classic. On the left, you tear a piece of paper. On the right, you burn it. Both actions change the paper, no doubt. But think about it. The difference is massive, right? One change is kind of temporary. You still have paper. The other, it's permanent. You've got ash. One just messes with the form. The other creates a whole new substance. And that difference is the key to everything we're talking about. All right, let's kick things off with the easier one to wrap your head around. Physical changes. The best way to think about it is like this. It's basically matter just getting a makeover. Yeah, it might look totally different, but underneath it all, it's still the exact same stuff. Okay, but before we can really get physical changes, we've got to talk about physical properties. What are those? Well, just think of them as a substance's basic stats. Like on a character sheet in a game. It's everything you can see, touch, or measure without actually changing the stuff itself. Water is a perfect example, right? We all know it's clear. We know its melting point is 0 degrees Celsius or 32 Fahrenheit. These are its physical properties. And the crucial part here is that we can figure all this out without doing anything to change what water is. We're just observing it. So a physical change is really just when one of these properties gets altered. Simple as that. But here's the big takeaway, the most important thing to remember. Even if it looks completely different, its chemical identity, what it's actually made of down to the molecules, hasn't changed one bit. It stays exactly the same. Think about it. When ice melts, it turns into water. But it's still H2O, right? And when you tear that paper, you just have smaller pieces of, well, paper. And here's the really cool part. A lot of these changes can be undone. They're reversible. You can take that water and pop it back in the freezer and boom, you've got ice again. So if you're going to remember just one thing about physical changes, make it this little mantra. Same stuff, different form. That's it. Pretty simple, huh? All right, time to switch gears completely. We're leaving the simple makeovers behind. Now, we're diving into the world of complete, total transformations, where you end up with something brand new. And this is where we get into chemical properties. Now, these are different. If physical properties describe what a substance is right now, chemical properties describe its potential, what it could become, its ability to react and totally morph into something else. I mean, think about it. You can't just look at a piece of wood and see its flammability. That's not a thing. You only find out about that property when you try to light it on fire. It's all about what the wood can do. It can burn, it can turn into ash and smoke. And that is a chemical change. You'll also hear it called a chemical reaction. It's what happens when that potential we were talking about actually happens. The original stuff, poof, it's gone. And in its place, you have one or more totally new things with their own new set of properties. And you see these things everywhere. When a nail rusts, it's not just iron anymore. It's this new flaky stuff called iron oxide. And you definitely can't unbake a cake back into flour, eggs, and sugar, right? No way. The change is permanent. So this leads us perfectly to our second mantra. If physical changes are same stuff, different form, then chemical changes are all about making something entirely new. That contrast right there, that's the whole ballgame. Okay, great. We get the difference in theory, but how do you spot it in the wild? How can you put on your detective hat and figure out what kind of change you're actually looking at? And honestly, this is the most important skill to have. When you see something happen, how do you know? Are we just changing its shape, or are we literally making something new from scratch? Well, the secret is to ask yourself one super simple question. Is the stuff I have now different from the stuff I started with? If the answer is yes, if you see a new color pop up, or smell something different, or you see light or feel heat being given off, chances are you've got a chemical change on your hands. And look, this is way more than just some dusty concept from a science textbook. Understanding this stuff and being able to control it is the foundation of pretty much everything we do. I'm talking from cooking dinner to powering our entire world. Let's take a look at a really powerful, everyday example, the engine in your car. A combustion engine.
It's this incredible piece of engineering, but when you boil it all down, it's just a machine built to control a very specific chemical change to get work done.
So here's how it works, step by step. First, you've got your fuel, your gasoline. Second, a spark kicks off that big chemical change, combustion, and that gasoline gets totally transformed. And what's the result? A huge release of energy that moves your car, plus a bunch of brand new substances like carbon dioxide and water vapor. That's your exhaust. See, you start with gasoline, but you absolutely do not end with it.
And that is why this all matters so much. Because engineers understand this exact chemical change inside and out, they can design better engines. Engines that squeeze more power out of every single drop of gas. And this is huge, they can tweak the reaction to create fewer nasty pollutants.
So let's bring this all back home with one final thought for you. The next time you're cooking, just for a second, think like a scientist. When you're chopping up an onion, that's a physical change. But when you bake a cake and you watch that gooey batter turn into a light, fluffy solid, bam, you're a master of chemical change. So my question to you is, what other transformations are you in charge of every single day?